Welcome back. We've now seen two recursive functions, factorial and string reversal. And we're going to do one more example, and then I'm going to have you do a couple of drills. I'm going to have you write both an iterative and a recursive so you can see how to think about these two things simultaneously. All right, here's the first one I want us to work on. I would like us to write a recursive function, mySum, that takes as input a list of numbers and sums them all up and gives me the sum. Okay? Here's a nice drill if you want to do one. Just do this iteratively. Okay? Almost everything we do recursively will have an iterative component and vice versa. They may be a little bit easier, they may be a little bit harder, or they may be the same. So if you want to take a break, go ahead and do that and write this iteratively. It's a good exercise. Okay. So the first thing first, and look, this is always true no matter when you're writing code, but more so when you're writing recursive code, you've got to really think about what is it that you want to do. So think about the recursive definition. Two parts, base case and then the recursive case. So what's the base case here? I can think of two possible. One is I give you a list with only a single element in it. What is the sum of all the elements of that list? Just that one element. What's the other base case? Yeah, just like before, if the list is empty. Let's do that one. That way we'll just go ahead and deal with the empty list. Well, now you got to ask the question is, what is my sum of the empty list? I think it's reasonable to return 0. We can say the sum of all of those elements is 0. So let's just go ahead and write the base case. If the list is equal to the empty list, so square bracket, I could have also said if the length of the list is equal to 0, that would have tested for the empty list as well. Return. Do not forget that you are returning values because recursively you are building up an expression as we saw with both factorial and with string reversal. So be really, really careful here. All right, recursive. What's the recursive definition? Well, what does it mean to sum up 2, 4, 1, and 5? Well, one way to think about it is the sum of all of these elements is 2 plus, well, whatever the sum of the rest of the list is. So I can just peel off that first element, hold on to it, and add it to my sum of 4, 1, 5. Yeah, that sounds about right. And by the way, that sounds a lot like factorial, right? N factorial is n times whatever the answer is for everything else. So here, instead of decrementing a value, I'm just taking one element off the list and then summing everything else. And that's sort of like what we did with reversal. We took one element off the list, we put it to the end, and then we reversed everything else up front. Same thing here. All right, so what I'm going to do is I'm going to peel off that first element, and then I'm going to add that to the recursive call of everything else. Okay, that should be pretty straightforward. So if L is the empty list, return 0, else grab the 0th element and add it to everything else recursively called with my sum. So again, the 1 colon operator says starting at position 1, which is the second element in the list, up until the end, grab that list, call my sum recursively, and then this will eventually return 4 plus 5 plus 1, which is 10, and it'll add that to 2, and I'll have my answer. And again, that return there is important. You are building an expression. You have to return something to the previous function call, whether it's recursive or whoever called you from the outside. All right, let's make sure we understand how this works. So let's walk through an example with this list with 4 elements. My sum of 2, 4, 1, 5. All right, let's go into the code. List isn't empty, so peel off the first element and add it to the recursive call of everything else. So that's 2 plus my sum of 4, 1, 5. Okay, am I done? No. I want to add 2 things, but that is a function call. So I eventually have to go call some function and get an answer, and then I can return. All right, what's my sum of 4, 1, 5? Come into here, that's not empty. Peel off the first element, make a recursive call with the next 2 elements. 4 plus my sum of 1, 5. Am I done yet? Nope, I still need this. Peel off the first element, recursive call. Peel off the first element, recursive call. Aha! You can see we're getting there, by the way. Now, this little guy is done. Why? Because it hits the base case. And notice the base case doesn't have to do any work. It hits the 0. So now, 5 plus my sum of the empty list says, please return 0 to my sum of the empty list. Now I have an expression, 5. And now I have the answer to my sum of 5. So I can pop that up to my sum of 5. Now I have an answer to my sum of 1, 5. It's 6. Now I have an answer to my sum of 4, 1, 5. It is 10. And now finally I have an answer which is 12. Okay? Good. All right, let's do a drill. I'm going to give you two back-to-back. So the first one is write an iterative function that takes as input an integer n, just a number, positive integer, and returns the sum of the first n integers. So sum 5, for example, will return 1 plus 2 plus 3 plus 4 plus 5. So this looks a lot like factorial. So do that, please, iteratively. While loop, for loop, I don't care how you do it. And then when you're done with that, please do exactly the same thing, but do it recursively. Okay, so two drills back to back. And go ahead and pause the video. Take some time to do those two. I think the iterative you should be able to do very quickly. And then again, think about the nature of the recursive call, base case, recursive call, and then come back and we'll do both solutions to this. All right, I hope you got the answer to both of those. So let me show you my solution. The iterative one, so sum iter, I'm going to just distinguish between the two types of functions, takes as input n, and again, I'm not going to check whether n is a positive integer. We won't worry about that. I'm going to initialize a variable to be sum. I'm going to initialize a variable called sum to be 0, and then I'm going to iterate between the values 0 and n. And notice here, this is an off by 1 error that may have bit some of you. If I want to use a for loop, iterating between 0 and n, I have to go from 0 to n plus 1 because this last value is non-inclusive. So the value of I inside the body of the for loop will take on the value 0, 1, 2, 3, 4 up until n. What do I want to do with those? I want to sum them up. So I'm going to say sum is equal to the previous sum plus I. Notice, by the way, unlike factorial, where we initialized the factorial to be 1 because we were computing products, and 1 is the identity for product, in sum, of course, we have to initialize at 0. Okay? So running sum. Each iteration, we add 0, 1, 2, 3, 4, 5, and then eventually we return sum at the very end here, and relatively straightforward. Now, you may have done this with a while loop, perfectly fine. I would argue the for loop is probably cleaner because if you're counting integers from 0 to some number, there's no reason for you to do it with a while loop. There's no reason for you to initialize a variable, do the condition, and then increment the variable. Let Python do the hard work for you. So I would argue probably the for version of this is a little tighter and a little neater because it fits very nicely into what exactly range designs for you. Okay, let's do now the recursive definition. Base case is easy. If n is 0, return 0. Right? So if I ask you to sum the first 0 numbers, I'm done. There's nothing to do. Okay, good. So that's easy. So what's the recursive definition? Well, let's see. The sum of n is, let's start from this side, 5 plus 4 plus 3 plus 2 plus 1. So surely we can agree that that's 5 plus the recursion of 4. And 4 is 4 plus the recursive call of 3. It's exactly like factorial, it's just that we're summing instead of multiplying. Okay, good. So let's see what that recursive call looks like. So if n is not 0, I'm going to take the number n, and I'm going to add it, not multiply it, to a recursive call of n minus 1. And eventually, so I'll make a recursive call here. I'll keep building up the expression. So it'll be n plus n minus 1 plus n minus 2, all the way down until we hit the 0, the base case. Okay, good. I hope you got that. By the way, some of you may be getting errors in Python or Jupyter Notebook saying recursion length exceeded. That's because it's sort of like an infinite loop. You keep going recursive calls, and it's not catching your base case. It's sort of the equivalent in iteration of that you're not stopping the loop. And that just means something's wrong with your logic or you have a little bit of bug in your code. So if you're seeing this stack overflow or cube blown out or recursion limit exceeded, something is wrong with the stopping condition on your code. All right. Now, at this point, we've seen a number of examples of recursive calls, and I'll be the first one to admit that they're relatively straightforward, and there's no obvious benefit to doing something recursively over iterative. Okay? And the last example I'm going to show you, I want to show you the power, the true power and beauty of recursion, and we are going to solve a fairly complex problem recursively, and you're going to see how truly elegant recursion can be when it's done very, very well. So we'll pick it up in a little bit when we come back.